Hey guys, so today we're going to be solving LeetCode question number 9, palindrome number. So let's read through the question first. Given an integer x, return true if x is a palindrome and false otherwise. And the definition of a palindrome is, so an integer is a palindrome when it reads the same forward and backward. For example, 121 is a palindrome while 123 is not. Okay, so let's look at some of these examples here. So we have x is equal to 121, and we output true because this is a palindrome. And the reason why is because 121 reads as 121 from the left to the right and from the right to the left. So 121 this way and 121 going that way. Okay, example 2, x is equal to negative 121, and this is false. So from left to right it reads negative 121. From right to left it becomes 121 negative. Okay, so negative numbers are not palindromes. And example 3, so x is equal to 10, and this is false because it reads 0, 1 from right to left. Therefore, it is not a palindrome. Okay. And our constraints here, okay, so 32-bit integer. And follow up, could you solve it without converting the integer to a string? Okay, so let's just solve this without doing that conversion right off the bat. So, and if we could convert it to a string, then it's a very simple question, right? We just get the integer, convert it to a string, and then we do some kind of loop, and we can just compare to make sure that it reads the same both ways. So, if we can't convert it to an integer, then we will have to, so I guess the first thing is, do we want to solve this using recursion or do we want to solve this iteratively? I think in this case, iteratively would be easier. I think if we do it recursively, there's going to be a lot of math involved. So let me start by grabbing this and pasting it in our drawing board here. Okay, so right, so I think the approach here we can do is, if we have a number, so like 1, 2, 3, 2, 1, and we want to check that it's a palindrome, one way we can do that is we can just we can create a number that reads the other way, right? So this is not a good example. So we'll do 1, 2, 3, 4. So we'll create a number 4, 3, 2, 1. And then at the end, we can just check to see, are these two numbers here equal? And if they're equal, we know it's a palindrome. If it's not equal, then we know it's not a palindrome. And in our case, we don't have to worry about potentially overflowing because of the number of constraints that we're given, right? So this is a 32-bit int, Python 3, which we're using. Integers can go up to 64 bits, so that's not going to be an issue. So we can go with this solution here. Okay, so let's go ahead and code this up. And just to briefly go over the runtime here, so to generate this reversed string here, all we have to do is do a single iteration through this. We'll create this, we'll do some math, and then we will basically do the comparison. So this will be an O of n runtime, where n is the number of digits in the input x. And just to briefly go over some of the math real quick. So if we're given this as the input here, and we want to output this as the output, then what we can do is we can grab this first integer here by doing a modulo, right? So we can do a modulo 10. So 1, 2, 3, 4 mod 10. That will just give us the 4 that we want. And so that's how we can parse out this ones digit. and then we'll have some kind of for loop, and we'll keep going through this integer. So we'll have to remove this, and then the next time we go through, we'll do another modulo, and then we can extract the 3, and we'll have to shift this 4 over by 1, and then we can add the 3 here, and then we can build it like that. So we can like go like this, right? So we can use modulos to extract the ones digit, and then we can do divide by tens to sort of um, keep shifting this over, right? Because if we have the number 1, 2, 3, 4, and we divide by 10, it's actually floor by 10, so divide and floor, then we'll have 1, 2, 3, right? So we essentially just remove that digit there. So we can use the modulo and the floor operation to sort of get to our reversed integer here. Okay, so we'll get into the coding now. So let's do some basic edge cases here. So we know that if it's a negative number, right? So if x is less than 0, so if it's negative, then we just return false. And that's example 2 there. And if we have a single digit, so if x is less than 10, then we can return true, because this will always be. So we know if it reaches here that it's definitely going to be positive. So then this will be checking if it's a positive number that's less than 10. So if it's a single digit, then we return true. Okay, so those are our edge cases. And now let's get into the core of the logic here. So let's see. So we want to have our original x. So we want to keep a copy of this value, and then we'll do a reversed x, and this will start at 0. And then here we're going to do that reverse logic. So we'll have a while loop, and we will modify the input x. So we know we're done when x has no more digits. So while x is greater than 0, we'll continue processing. And what we'll want to process is, so we want to do reversed x is equal to reversed x. Okay, so this is where we get that ones digit from the input x. So we'll do our x mod 10, right? So this will grab that one digit from the input, and then the next time through, we'll have to shift this over, right? So let's go ahead and do that. So reversed x is equal to reversed x times 10, right? So the first time through it will be 0, so this will not do anything. And then it will be 0 plus whatever that ones digit is here. And then reverse will now be 1 at this point. So reversed is equal to 1. And then here we will decrement this counter. So we've already processed that first digit here, so now let's go to the next one. So let's go ahead and x equals x 4 by 10. So this will shift this 1 away, so now we're only looking out. So x will be equal to 1, 2. X equals 1, 2. And reversed x is equal to 1, okay? And then we'll go through again, and at this point x is 1, right? Reversed x is 1. We shift 1 over, so now reversed x will be 10. And then we grab the ones place from this x, which is a 2, and we'll add it to this. So now it'll be 12. And then we're going to remove the 2 here. And then we go back here and we do the same thing. So we're going to shift this over. So it's going to be, so this is 12 at this point, and we're going to shift it over. So it'll be 120. Let me make room for this ones digit here, which is a 1. So now we'll add the 1 there. And then at this point, we'll remove that last value. So we've processed x completely. So now we're going to exit this while loop. And here we're going to, so now we have our reversed x, and we also have our original x. And so now we can do is palindrome is equal to reversed x is equal to original x, right? So this will tell us if it's a palindrome or not, and then we're going to just return whether it's a palindrome or not. Okay. Let's remove these comments here, and let's go ahead and run this. Okay, and we passed our test cases, so let's go ahead and submit this now. Okay, awesome. So we passed all the cases. And one more note here, so before we end this off, if you are constrained here, so for whatever reason the language you're using only has an int of a 30 of this size, then you can modify this logic a little bit. So you don't have to reverse the whole input. You can just reverse half of it, right? Because once you get to the halfway point, then you can just compare that with the halfway point of the original, and that will also be a valid way to do this. It adds a little bit of complexity, but that will allow you to sort of satisfy this constraint if whatever language you're using has that limit on the int size. Okay, and if you have questions around that, feel free to post them in the comment section below, and either I or someone else in the community can assist you there. Okay, so that's it for this video. I hope you enjoyed it, and I hope you found this helpful. If you have questions, feel free to post them in the comment section, and don't forget to like and subscribe this video.